Correlation versus causation. So it says two variables are correlated when there's a relationship between the two. When the two variables increase together, they are positively correlated. When one value increases and the other decreases, they are negatively correlated. So number one says, which of these scatter plots show correlation between the independent and dependent variables? Is there a positive correlation or a negative correlation? So we're going to write positive correlation, negative correlation, or no correlation. Okay, so if I look at this first scatter plot, I have fuel remaining in a car and miles driven. These are the two variables. And if you look, as the miles driven goes up, as we go this way, the fuel remaining goes down. So this is a negative correlation. And it's quite strong, actually. Look how close the dots are together. And it should be, right? The more you drive, the more fuel is going to be expended, and you're going to have less and less. So there's a negative correlation there, and that makes sense. On the second one, we have age and salary income. And as age goes up, salary income goes up. So I'm going to say this is a positive correlation. Now, it's not as strong, like the dots are a little more spread out, right? But there's a positive correlation there. It's not. I'm not saying it's not as strong as the car example to the left. Height and grade point average, like there's no correlation here. There's no trend. It's just a bunch of random dots spread out. This is no correlation. And it wouldn't make sense for there to be correlation, would there? Height, grade point average, that has nothing to do with anything. How tall you are has no impact on how you do in school. Like, this doesn't make any sense for there to be any correlation anyways. Age and salary income makes some sense, right? Because you get promotions as you get older and older and older, stuff like that. So there's a little reason for there to be some positive correlation there. And then miles driven and fuel, of course there's going to be correlation there, because the more miles you drive, less fuel remaining in the car. So keep that in mind. So now I've kind of touching on this a little bit, and we have this new term here about, we call this causation. So this is kind of a really tricky idea. We have correlation that's just saying, okay, look at the graph, are they correlated? And now we have causation. And causation is when one variable explicitly causes, that's why it's called causation, the outcome of the other variable. So this can get a little tricky. It says causation and correlation can exist at the same time. However, correlation does not imply causation. Just because two things are correlated doesn't mean that there's causation between them. So here, let's look at number 2. Hopefully these examples are clear. It says the following scatter plots both show correlation, but based on their variables, which scatter plot implies correlation with causation and which implies correlation without causation? So I was kind of talking about this already, but this one is, I'm just going to tell you the answer right off the bat, and then I'll explain it. This is correlation with causation. Because the more you drive, the less fuel you'll have in your car. That's just a straight up fact, right? Like, there's no ifs, ands, and buts about it. It's just the more you drive, the less fuel you're going to have in the car. Driving causes your gas to run out. That's it. Driving causes your gas to run out. There's no other variable that has any impact on this. Driving causes your fuel to run out. Now this one, I'm going to write the answer and explain it. This is causation. Sorry, not causation. Correlation, because it's correlated, positively correlated, right? This is correlation without causation. Now let me explain. So this one's without. Sure, there's correlation between age and salary income, but this is not causation. Being older doesn't directly, explicitly cause you to make more money. Just because you're older doesn't make you more money. Sure, there's a relationship, because as time goes on, you most likely get some promotions and stuff like that, but it doesn't cause you to. it could have there's other variables in play here. It could be the job you picked, right? Like if you chose to be a doctor as opposed to like a teacher, doctor's going to make a lot more money. That's another variable, is choice of what you became to be, like how hard you work, right? Just because you get older doesn't cause you to get a promotion. Like there's different variables in play here. This age doesn't explicitly cause your salary to go up. So there's correlation, but it's without causation. So a lot of these you're really going to have to think in your head, and you can make arguments for both sometimes, but you really got to think these through. Okay. So I'm going to do a few of these. So determine whether the following relationships imply correlation with causation or correlation without causation. So A says the more time someone exercises, the more calories they burn. This is correlation with causation. Because the more you exercise, you're going to burn more calories. That's what exercising does. You burn calories. That's with causation. I don't really have another way to explain it, but it's kind of like the car problem, right? But the more you exercise, the more calories you're going to burn. That's just how it works. B says the more computers in a house, the more expensive the house will be. This is without. Now, with no doubt in my mind, there's a correlation here. If you have an expensive house, more than likely you're going to have more computers in your house than a least expensive house. And that's just because people with more expensive houses probably have more disposable income and probably are richer and probably can afford more computers. So they're going to have more computers. They probably have more rooms, have more tablets, more whatever. They're going to have more computers in their house. There's probably a correlation there. It might not be the strongest correlation, but I imagine a rich family is probably going to have more computers in their house with a big home than a poor family, right? So there's correlation here, but that doesn't mean it's causation. Just because you have a more expensive house doesn't cause you to run out to Walmart or Best Buy or wherever, Target, and buy more computers. There's not causation there. There'll be correlation, but having more computers doesn't cause you to have an expensive house, and having an expensive house doesn't cause you to have more computers. There's not causation there, okay? See, let me just show you one more. The less time you spend on your phone, the higher your school grades. So this one's, a little trickier. So there's correlation here, but this I'm also going to say without. But you might battle me on this one and say, oh no, if you spend less time on your phone, yeah, you're going to get higher grades because you're going to be studying more, and maybe you'll get more sleep, and maybe you'll spend more time on homework and stuff like that. But that doesn't cause you to do that. Just because you're spending less time on your phone doesn't mean that all of a sudden your grades are going to go up. There's other things that come into play. It's maybe your IQ, maybe how much time you're studying. Not spending time on your phone doesn't automatically make you get higher school grades. It doesn't cause you to get higher school grades. There's a correlation there, probably, right? Because then you do have time to study and you're not checking, Instagram and all this stuff, and you're more focused on your studies, probably. But this isn't a strict causation. Okay, this doesn't cause you to get higher grades. So this really think about the word causes. If it's explicitly causes, then there will be causation. But if it doesn't, then we're going to say without causation. So there'll probably be some good conversations you can have with people based off of these, because your opinions might kind of, you might disagree on some of them, but as long as you got reasons to back it up, that's important. So I'm going to let you play around with the rest of this page here and determine whether or not it's correlation with causation or correlation without causation.